Okay, ladies and gentlemen, thank you very much indeed and welcome back. Now, let's move on to the next session, and this is all about putting AI into retail. So to discuss this further, I'm delighted to welcome now Robert Saxby. He's Big Data Product Specialist at EMEA Google Cloud. Put your hands together, please, for Robert.
Hello. Okay, just checking the microphone. Hi, I'm Robert. I work at Google Cloud. I guess since this is Retail Week, I should also make a small confession. Before I worked at Google Cloud, I worked for a big online retailer in Holland called Coolblue, in case any of you are familiar with Coolblue. So I have some experience in this area. I led their data engineering team. So a lot of what I'm going to talk to you about today is going to be about data engineering, machine learning, AI, and how we can approach that in retail. So I'm going to start off with a little anecdote that I like to tell, thanks to my daughters. I have two daughters. One is 9, the other one is 6. And 9, she's 8 still, I should remember. I always get these things wrong. So she's 8 years old, and she had to fill in her homework. One of the things that she was asked to do was to kind of write down all this stuff and like what she's doing, what she likes. And she had to ask me to, do the same thing. And one of the questions is, what are you reading at the moment, or what are you interested in at the moment? So I read, well, I'm working on this machine learning stuff, so I'm reading about that, and this is what I'm learning about. And she said, I'm going to put down the same thing too. And that made me think for a moment, it's quite a big discipline, AI. There's a lot going on. And I think, everyone can participate in some way. Obviously we have data scientists and, who have PhDs or are working on new types of algorithm and new types of models. But we also have data engineers, but we also have analysts. But more than that, we have everyone that's kind of involved. And as our world changes, as we come into this environment where AI is going to be more of a part of the products that we use, I think it's really important for all of us to have a kind of shared understanding how that works in some way. So hopefully, as well as today showing a bit of what's possible, I will also give some, at least, information which will help, understand a little bit how this has worked and how it's being used. So Google's mission statement has been to, kind of organize the world of information and to make it useful and accessible. And I think we can all agree that AI is a good extension of that. So if you think about, for example, taking unstructured data like images and working out what's in those images so we can use that information. That's just another way in which we're kind of expanding the definition of our mission. That's why I wanted to start off with this slide. So right at the beginning, this has been an important theme for us in the last couple of years, is defining which principles we want to kind of employ when we're approaching AI. And I'm not going to go through all of them, but I'm just going to mention one of them, which is about unfair bias. So if you think about training your models, if you think about what these models might be used for, let's take a simple example like recommendations. So we're going to have some kind of model, and it's going to recommend us the next best product. That's awesome that we can do something like that. But if we don't have a data set which encompasses all of the people that might be interested in our products, it's not going to work for them. So this is one to kind of think about, and obviously all the rest here are very important as well, but I just want to kind of give you an idea of some of the responsibility in this. If we take some of the things that we're maybe doing now, or some of our shortcomings that we have now, and we don't try to improve them as we automate this stuff with artificial intelligence and machine learning, we will inherently, bring that same thing to the new set of products that we create for our audiences and our customers. So let's get down to business. So retail. Well, first of all, AI and machine learning is really across industry at the moment. We're working in all of these verticals, and we really see how it's being used for different applications. So I've just highlighted some of the ones here that pop up in retail. Things like predictive inventory control, things like recommendations, sentiment analysis. But if you look at some of the other ones that are there as well, you'll see that they're not exclusive to those industries. They really kind of stretch across all industries. So we will go for a few of the examples of retail as we go through this presentation. So I added this slide today, so it's going to be a surprise for the people that checked my slides earlier. The reason I added this, I want to go back to the example of predictive inventory. So imagine that you're trying to predict which inventory you need. So which products do you need to have in your warehouse in order to be able to supply your customer as quickly as possible? There's a lot of work that goes into that. There's a lot of data you need to collect. There's a lot of different algorithms and approaches you can take to actually solve that problem. But one of the important things here is that this is very much a operationalized, a real-time thing. You know, you don't want to be stacking up on your inventory that you might need in 6 months' time, maybe, if that product does well in the market, but you do want to have the product that your customers want tomorrow, today, so you can deliver it to them tomorrow. So being able to automate that, being able to understand what the consumers are looking at, what they're asking for, you know, how prices are changing, all those data points that kind of go into predicting whether you're going to be selling more of one product or another is very useful if you want to operationalize that thing. And I kind of put this slide here because a lot of what we've done in the past, or where we're coming from, especially if you've been working in business intelligence or you're working as an analyst, it's either been some kind of operational reporting, where we kind of report on the state of the business, or it's been like ad hoc. Someone says, I've got this problem. Can you like create a report to explain what's going on here? Or a little bit deeper where we do an analysis, like an ad hoc analysis. This is going wrong now. Why aren't we getting any traffic to our site? Like, or why is the traffic being reduced to our site at the moment? So you kind of dive into the data and you explore what's going on. But if we can kind of shift all of that up into this operationalized segment, or that quadrant in the top right-hand quarter, then we can kind of take advantage of our data and start making it work for us as we try to, you know, as our customers are actually on our sites or in our stores trying to do something. And I think that's a goal that we can all probably aspire to. So here's a use case. Let me just grab some water. eBay, one of our customers, they were doing a visual search. Now, I'm just going to put this up here as a retail example, but just to illustrate another point. So they're searching images. So you see here there's like 1 billion products that they have in their search listings. And as you upload an image or explore it, you know, with your smartphone or wherever else, you want to basically find that product or find a similar product to that. So visual search is a useful tool, especially, you know, when you're exploring like your environment and the different, the pair of shoes, if you like green, you know. I won't say the brand, but I guess you'll know. But you might take a photo of those and actually want to find those, or where I can get a pair. So they do this on their own models. They've been training their own models. But one of the things that they wanted to do was to get, you know, better accuracy and to be able to do it faster. Because, you know, the products are changing, the market's changing, so being able to retrain that model means that you're capturing that new information as well. So one of the ways that they did this was to run this on Google Cloud, and they did it by actually taking advantage of some of our hardware called TPUs. Now, I'm not going to run through all the numbers, but I just want to kind of bring some attention here to what's going on in the industry. You know, we are asking more and more from our computational models. We have more data points. Like an image model, which I will show a little bit later, has something like 30,000 million parameters. So you can imagine if you're training this and training this with new data and trying to improve the accuracy, you need a lot of computational power. Moore's law is kind of flattening out. It's not the same as we were seeing in the past. So the only way for us to be able to achieve this is by actually designing hardware which is specific to this task. So you may have heard of GPUs. TPUs are tensor processing units. Tensor is if you study physics, you know, it's just a matrix with like multi-dimensions. But this kind of represents your features in space. So being able to do this quickly and train our models with this kind of data means that we can get like fresh models out there, more accurate models. And that goes back to the case with eBay. So we're going to look at 3 approaches. We're going to start off with our data and our models, and I'm talking about our now as Google, or the provider of these models and data. And then we will move to the spectrum with your data and your models and look at the differences. So our data and our models. At Google Cloud, we offer a whole bunch of APIs which you can use, you know, just by running on Google Cloud, calling out to an API from your application, and then you have some ability which is tied into a machine learning model and the data that we've trained it on. So, for example, sentiment analysis. Imagine, for example, your products are being and your company is being discussed on social media. And you really want to kind of, there are many streams of social media that you might want to actually, look at and understand what's going on. Now, you could take an army of people to capture all that information and reply to that. you might want to automate some of that. So let's think, for example, that if someone's saying, oh, I really like this company, they're doing such a great job, that's awesome, we should say thank you, or ask them how things are going or something like that. If someone is on Twitter and they say, oh, I just got this product delivered and it was broken again and again, like that's something you want to solve. So being able to automate that flow will allow you to actually go and direct your workforce in that particular example to go to the most important or the most pressing thing that they need to do. So how would that work? We would take that text, we would do something called natural language processing, and we would extract things like the sentiment of that text, the different entities, the things that are being discussed. Now this is a model that we've trained on our data and we've made available through our API. Sentiment, general sentiment of things like in social media might be good enough for your use case. It might not, and we'll look at that in a moment. So actually, to look at that, we're going to look at vision. So let's just take that vision search again that we spoke about with eBay. So imagine you use our API for analyzing images. So you upload an image to the API and you get a response back. And it will tell you some useful things like, this is an elephant, or this is a shirt. If it has text, you could actually, through OCR, extract the text information. You could detect if there was explicit content. These are all useful things, but it doesn't really help you with your product line actually provide a visual search. So one thing you could go and do is, build your own model. But as I just said, some of those models for visual search actually have 30,000 million parameters, which is a lot. So we're going to have a look at this next option, which is basically using your data and our models. And this is what we call AutoML. So let's take that example again of visual search. So on the left-hand side, we have, we run it through the API and we get back the information as a cat. Obviously, I know everyone is selling cats here, so this is really a good example. But I was going to put some product, but then I thought I'd get the wrong product for half the audience, or someone would be really happy. But everyone likes cats, no? At least I do. We're a dog company, by the way. We get this information back as a cat. But for me specifically, I don't want to know it's a cat. I want to know it's Chloe, or I want to know what breed of cat it is. So if I have that information, that data, so I have my data set and I have the labels that are important to me, you can bring that data and we can actually retrain our models. And by retraining, that's things like transfer learning, so stripping off some of the layers of the models and applying using your data to retrain that layer of the model. It might be something where we actually decompose some of the model and reassemble it in a different way because it works better for your particular problem space. These are all the things that we're doing automatically behind the scenes when you train one of our API models with your data. So we call this AutoML. It's your data, it's just available for you, so that's important, that aspect of privacy. I mean, it's not that unless you permission someone else to use it, which is on your control plane, no one else can actually use that, but you, from your programming, your applications, will be able to use this model. So this gives you a very unique capability. You don't now need to go and create this model, which is quite complex. You can bring your data to bear on a model that already exists. So this kind of highlights how it works, but just to give you an example how effective this is, that red line at the top is the performance of AutoML for image recognition. And that black line are some of the most well-known and most performant models that are out there in the image space. Things like Inception and ResNet, some of you may have heard of those. So as I said, look here, with 25,000 million parameters, AutoML has got an accuracy of above 80%, which outperforms a lot of the other existing models. So just something to think about. If you're looking for that particular capability, this may be one approach, one direction you choose to take. I spoke earlier about the democratization. So I spoke about how important it is for people to actually be able to understand how these models are working. But it's also super important for people to be able to work with them, to ask questions as well. So let's think back like 10 years when we were all using spreadsheets on our desktop. You would have your small data set there, and you could do something like a linear regression. You could draw a line, you could understand, oh, look, sales are going up. I predict they're going to go up next year as well. That becomes a whole lot more difficult when your data sets are in the hundreds of gigabytes, hundreds of terabytes, or petabytes. It doesn't fit in your spreadsheet anymore. It doesn't even fit on your database in your server. So one of our tools that we use in this space is called BigQuery. And all I really want to kind of show here, without going too much into the product, is just some of the other developments that are happening in this area to actually bring the power of AI and machine learning so to really bear on multiple use cases and in multiple environments. So this BigQuery is a data warehouse. Its interface is SQL. Most people have worked with SQL at some point in their life, select star from table. Some of us have spent many more hours working with SQL and done some crazy stuff with it. But it is a universal language, especially for analysts and developers alike. So being able to have such a common language as everyone is using with a whole array of different programs, being able to use that in a data warehouse, that's normal, that's what I would expect. But this next part is being able to go and ask those same questions. So the things that we can actually do in this space at the moment is linear and logistic regression, and we're doing more. But we do this for a SQL interface. I have a little animated GIF here, which just basically shows you what this looks like. There are two steps. There's the training step, and there is then the inference step, the prediction step. And imagine you have a data set, and you're looking at, so what's in this data set? I think it's something like bicycle rides or something. And you want to predict how many rides are going to occur over a period of time. Like, this is how easy it is. Selecting from that table, saying which is the label, which features you want to pull out, and then actually running a model and then using that for prediction, all through SQL. So this is just another dimension, another way in which your analysts and engineers can actually start using some of the power of machine learning to ask questions of their bigger data sets. So this last thing is where we go a little bit more down the rabbit hole, just a bit. It's about your data and your models. So I can imagine a whole host of scenarios. You might be working at a company where you don't have data scientists, and you think, we want vision search. That AutoML is just a ticket for me. You might be working at a company where you have a whole team of data scientists, in which case they might say, well, if we can use that API for vision search, maybe we can use the results from that to do other things. So you can see, like, it's not just because you're one type of person, you necessarily need to use just one type of product. It's really across the board. But when it comes to the models that you're creating, your data scientists are creating, and your own data, like, there's a lot on offer at this space. So I'm just going to show a few things and just show how this space is growing. So TensorFlow is our own machine learning framework, which we open sourced. By open sourcing it, that means it's basically everyone's machine learning framework, and everyone is contributing to it as well. Just to give you some idea, there are 1,600, so I took this from GitHub's page, there are 1,600 contributors at the moment, and this thing has been starred more than 100,000 times. So this, in terms of fork, 66,000 times. When people fork something in GitHub, it means that they've actually taken a copy because they're working on it to try out implementing different things. So there are two models of engagement here. There's actually creating and adding functionality to the framework, to the project itself, and then there is using that framework or project to actually go and train, to create your models and train your models and predict on your models for your particular problem. So there are two parts of that engagement. This is what TensorFlow looks like. There's a lot of details here, and if you're not familiar with it, it's probably like, whoa, what's going on? But I'm just going to highlight some of the layers which are important. So the bottom layer is about talking to different hardware. So this TensorFlow, the whole core of what it's doing is enabling you to run these models, to train these models, and predict on these models on different types of hardware. What does that possibly mean? Well, imagine that visual search, for example. Maybe you want to have a visual search model which runs offline on someone's mobile. So that model needs to be able to predict and work offline. Maybe it's such a big model that you need to train it in the cloud because you need more resources. So it needs to be able to work in a distributed fashion, and it needs to be able to take advantage of different types of accelerators, like those TPUs, to be able to run faster. As we go up into that block in the middle, that yellow block, what we're looking at there is all the different layers and how that actually functions. But the thing I'm going to kind of bring us to very quickly, because I'm running out of time and it's flashing at me now, is the top layers. These top layers, they're called estimators. So one of them, the red block there, is Keras, is a very popular layer which is used with different types of machine learning frameworks, which you can also use as a back-end TensorFlow. But on the estimators there are actually things for common problems which have already been defined. There are pre-made estimators, which enable people actually developing their own models to accelerate that whole development process. So just to give you an idea what that looks like, and yeah, if you have questions on it, please come and ask me or our team at the booth. I was supposed to put a thank you slide in. I didn't. I wanted to finish on this slide, because all of what I said, all these capabilities are awesome, but if I can leave one thing to take away, it's not just about the AI and the machine learning. It's about your data, it's about preparing that data, it's about everything that goes around that as well. It's about how you serve your predictions. So all these things. So this pipeline here is just to give you an idea, an impression about the different components and the different tools and products that you need to be able to do that whole flow. So this is not something in isolation. If you're going to go down this path and you're going to start using more AI machine learning in your products, just make sure that you bring like your whole resources to bear on this problem. So your developers, your analysts, because they all play a role in this. So hopefully this has been useful. Thank you very much.
Robert, thank you very much indeed. Now, I know it's flashing at you, but I think we've got time for one question. So if we can get the Slido up, I know that there is a question there for you. So let's just take these very briefly before we move on to the final panel before lunch. There you go. You can see that one. How useful is implementing AI for SMB with a limited budget?
Well, hopefully that question has been answered a little bit by the presentation. There are a number of different options, and not all of those options require you to go and spin up your own teams to be able to have those capabilities. And I think it's really important that those capabilities, not just the ones we expose, but other companies as well, are really available across the board, because everyone really needs to have a chance to bring this functionality into their products, because we want products that are competitive. So being able to, let's take that visual search, being able, if you don't have the team to, like eBay did, to go and create their own model and train their own model and leverage this hardware, like that requires quite a few resources, you could use an AutoML API to actually go and bring your data and train that model for your own visual search. So that's one example.
Okay, all right. And would you have a chance just to answer the second question briefly?
The second question. As I pointed out, that bottom layer addresses the different types of hardware. So there are two ways that this either happens. I'm not sure if it's available at the moment. Typically, when I train with GPUs, I do it on the cloud, on Linux boxes in the cloud, because my Mac here doesn't have a whole bunch of GPUs that I can use. But saying that, I mean, I did do some training on a GPU with TensorFlow on my laptop before. It does require you to go install a number of drivers, like the NVIDIA drivers, and then there's a layer in between as well. I forget the name of it, which you actually need to be able to do to make the translation from the NVIDIA drivers up to the TensorFlow. So there are options for that. So if that is your question, either reach out to me or someone at the booth, drop your email, and we can send you the details.
Robert, thank you very much indeed. Because of time, we will say thank you for now, but I'm sure you'll be around later to talk to people.
Yes.
Yeah? Lovely. Thank you very much. Robert Saxby.